experiment brings together the elements we need for electromagnetic induction. These are the principles behind which an alternator operates. It requires a magnetic field, a coil of wire and relative motion. And so I hope this helps you as we build up the principles behind the operation of a generator and an alternator. In this experiment, we're looking at the work of Michael Faraday. That is the work to do with electromagnetic induction. And Faraday did a whole lot of experiments. What he used was some magnets and some coils of wire. And what he discovered was, when there was relative motion between a magnet and a coil of wire, he produced this phenomenon we know today as electricity. He created an EMF. So let's go ahead and look at how this actually operates. We're going to be using a weak magnet and a few turns of wire. Then we'll increase the strength of the magnet and we'll use a strong magnet and still a few turns of wire. Then we'll increase the speed. The next part of the project, we'll get a coil of wire with a lot more turns. We'll return to the weak magnet and see if that improves our output. Then we'll use the strong magnet. And in this way, we're going to build up the principles that are behind how an alternator works and how we generate an EMF using electromagnetic induction. Let's move to the experiment. Starting with a weak magnet and a coil with a few turns of wire, if you look very closely at the meter, whilst I have motion, you'll see the tiniest movement of the needle. This would have been very, very hard to detect, but we can see a small amount of movement. Now, it's hard to see, so I'm going to replace the weak magnet with our strong one. And as the strong magnet moves over, you should actually detect the needle moving upscale and then downscale. Take note that when the magnet's stationary, the needle is also stationary. So we're generating AC. If I increase my speed a little bit, you also may notice that the needle moves more vigorously. We're going to replace then the coils with a few turns with some coils with a lot more turns of wire. So we might have about 10 turns in our first case, but now we're going to move to a coil of wire with something nearer 20 turns, probably 200 turns. So let's see what happens. We'll get our weak magnet and we'll move our coil. You should notice a deflection on the needle. It's not very great, but we can notice it. What we'll do now is we'll use our very strong magnet, and again we'll move our magnet in and out of our coil. Or I could move my coil in and out of the magnet. Either way, we just rely on relative motion. So if I increase the speed, I'll actually be making my needle move quite extremely. So here we've shown you that we've built up the principles of electromagnetic induction.